Good afternoon, parents of Mr. and Mrs. Smith, parents of Tim Smith. I'm very sorry to hear that your son was diagnosed with Duchenne muscular dystrophy, but our hospital is going to be here to take care of you every step of the way. Today, we're just going to be talking about kind of the basic science of the disease and some treatment options that we're going to explore. So, starting at the basic science, DMD is a progressive muscle wasting disease, meaning that over time, Tim's muscles are going to slowly waste away. He's going to lose his muscle tissue, and it's going to be replaced with fat and dead muscle tissue. Uh, the mutation occurs on the DMD gene, which produces dystrophin, a protein that protects muscles as they contract and relax. In a healthy person, that protein keeps the membrane from tearing. But in an affected person, where there is no dystrophin protein, uh, those tears in the muscle uh, membranes are going to happen. Um, this is just another view of what an affected muscle tissue looks like, where that dead muscle has been replaced by fat and fibrotic tissue. The reason we don't want the cell membrane to tear in muscles is because it will start to leak important nutrients and allow calcium to get into the muscle, which is uh, cytotoxic and kills the muscle cell almost immediately. Of course, we identified Tim at 3 years old, but DMD is typically identified in children under 2 years of age. Um, Infants, we typically see this Gower sign where they use their hands and knees to support themselves as they stand up. This is because of weakened muscles in the back of the legs. And we also see enlarged calves where those muscles are starting to be replaced by fat and fibrotic tissue. Right now, Tim is only starting to experience the difficulties of these weakened muscles, but as the disease progresses, he's going to accumulate more fat, lose more muscle, and likely need a wheelchair by the late adolescent, early teenage years. Um, Lung and heart function are also going to decrease as we progress into those teen years, and later in life, we're looking at major muscle failure and organ failure as a result of the lack of dystrophin. DMD is only found in males. On rare occasions, it's found in females, but typically, since it's carried on the X chromosome, it's only found in males. Um, if Tim were to have children, the likelihood of whether or not his children have DMD is entirely dependent on if the mother is a carrier or not a carrier, because he is only going to pass down his Y chromosome to a male child and his unaffected X chromosome to a female child. So some of the possible genetic treatments we're looking at are AAV, adenovirus mediated gene therapy, where essentially we inject a virus into the muscle cells. This virus just has sort of a package of DNA that the cell transcribes into that functional dystrophin protein, which can be used to protect the muscle cells and kind of slow the progression of DMD. Um, in a few cases, overactive immune response towards the vector can hinder the application of gene therapy, meaning we don't see very dramatic results, a dramatic improvement in the amount of dystrophin produced. But clinical trials are ongoing, so we're going to stay hopeful for that. This is just a visual diagram of how that works, how we inject the virus into the muscle cells, and then as it passes into the cell, its DNA is transcribed in the functional dystrophin protein. Another possible genetic treatment is using a chemical called eteplirsen, which can resolve point mutations on the dystrophin producing gene. Of course, only 14% of the cases are account for these point mutations. We're still waiting on test results from Tim, but in the case that it is a point mutation, this just allows um, the 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 protein that transcribes the DNA to skip over the affected codon in the DNA sequence, essentially where the DNA would tell the protein to stop making dystrophin. We can kind of run that stop sign using eteplirsen. Over repeated doses, eteplirsen accesses more muscle fibers, allowing for more dystrophin positive fiber production over time, meaning that as we do more doses, we see a gradually increased response and more dystrophin produced. There are also significantly fewer side effects associated with this treatment. That's not to say the other treatment isn't going to help slow the progression as well. Um, Clinical trials are still happening for both. So we're gonna just play the waiting game until we know whether or not Tim has a point mutation and go from there. But if you guys have any questions, the hospital is always here to support you. Thank you for joining this Zoom call. Contact you with the results.